Hello, this is Mr. Stansbury. I'm going to take you through some of the problems on the 5H assignment. Okay, first one we're going to take a look at is number 2. 2E, find the sum of the following series. Okay, so we have our formulas over here. So first we have to figure out if it's arithmetic or geometric. So you can tell since it's positive, negative, positive, negative, positive, negative, it's definitely going to be geometric. Oops, except for now I colored over the top of our formulas here. So we know u sub 1 is 6. To figure out r, we can do negative 3 divided by 6 is negative 1/2. And then if we do 1½ divided by negative 3, that gives us negative 1/2 as well. So you can keep doing that, and over we're going to figure out that r equals negative 1/2. I'm going to put 0.5, make it a little bit nicer for us. Okay. So now that we have our first term and our common ratio and the number of terms, now we can plug it into this lovely formula here. Okay, so sum of the first 15 terms is going to equal u sub 1, which is 6, all times r sub n, which is negative 0.5 to the 15th power, all minus, let's see, let's do this, that to the 15th power minus 1. Okay, and then divide that whole thing by our common ratio, which is negative 0.5 minus 1. So just to make this a little easier on the bottom, negative 1.5 for our denominator. And then let's see what we can calculate for the rest of this stuff here. So let's work from the inside out. So we got parentheses negative 0.5. You're going to want to do parentheses because we do negative 0.5 to the 15th power. It's going to give us negative 3. Actually, if you did it without the, if you did it at 0.5 to the 15th, what the calculator does is does 0.5 to the 15th power and then takes the opposite of that. So if this was like an even number, this would still, if you didn't put it in parentheses, this would still give us a negative number, which we know is not correct. So anyway, so there's our, this part right here, negative 0.5 to the 15th. Now we want to subtract 1. And then we want to multiply that thing by 6. And then we divide the whole thing by negative 1.5, and we get really close to 4. So sum of the first 15 terms is pretty close to 4. Now some people are saying, wait, look, you got all those numbers, 15 terms, how does it end up to be just 4? Well, one, you're subtracting, every other one is a negative, and also the numbers are getting smaller and smaller. That's why that's such a small value there. Okay, number 3, find a formula for S of n, the sum of the first n terms of the series. Okay, so again, 12, 6, 3, 1½ that looks like we're, this looks like it's geometric, so let's just double check it to see. 6 over 12 is 0.5, 3 over 6 is 0.5, 1½ over 3 is 0.5, so that means our common ratio is 0.5, and then our first term is 12, right? And it says, all it says is just find a formula for S of n. Okay, so we'll just plug that, all the info that we have into our S of n formula. So we can say S of n equals our first term, which is 12, our ratio, which is 0.5 to the n minus 1, all over common ratio 0.5 minus 1. Now, I'm okay if you just leave it like that. That's pretty good solid formula. You can simplify this. We know that this down here is negative 0.5, right? So if you take 12 divided by negative 0.5, you get negative 24. 0.5 to the nth power minus 1. And that's S of n. And the book just went through and multiplied everything by negative 1 to make it look prettier too, but that would be totally fine. I wouldn't keep going. Okay, number 5, evaluate these geometric series. So this is saying you're starting at 1 going all the way up to 10. So we know our n, there's 10 terms. Our first term is 3, and our common ratio is 2. So we have all of our important information. So let's plug it into our S of n, because this is definitely geometric, because whenever you start getting to the powers, that's geometric stuff here. So sum of the first 10 numbers of this series is going to be, u sub 1 is 3, our common ratio is 2, our n is 10, 2 to the 10th minus 1, all over 2 minus 1. So that just turns into 1 down there. So if we plug this in, 3 times 2 to the 10th, get that out of the power there, and then minus 1, and that all equals 3069. So sum of the first 10 terms of this series is 3069. Okay, number 8a here. Paula started renting an apartment. She paid $5,000 in rent the first year, and the rent increased by 5% each year. Find the nearest $10 the rent paid by Paula in the fourth year. So we're not looking for the sum. We're looking for just how much she paid in the fourth year. So we're going to want to use this u sub n. Okay. So the amount in the fourth year is going to be our u sub 1, which is our original amount, 5,000. And then times our rate. Okay, now our common ratio. You start with 100% of the 5,000, and then you're adding 5% each year. So that's 105%, which is 1.05 as our common ratio, 1.05. Okay, and then it's r to the n minus 1. Fourth year is 4 minus 1, so do that in our calculator, and we're just going to, let's see if I can't get there we go, 5,000 times 1.05 to the, we just do 4 minus 1, that's to the third, and it's 57.88, says to the nearest $10, so it's 57.90. Oops, 57.90 in the fourth year. Okay. 11, a geometric sequence has first term 6, common ratio 1.5, and the sum of the first n terms of the sequence is 79.125. Find n. So the sum of the first n terms is this. So we have to use this S of n because it's talking about sum, right? So S of n equals u1 times r to the n minus 1 all over r minus 1. We know the sum is 79.125. First term is 6. Common ratio is 1.5 to the n minus 1 all over 1.5 minus 1. So we're just trying to figure out what that n is right there, right? So let's try to simplify this side as much as we can. 1.5 minus 1 gives us 0.5. So then what we can do is we can actually take 6 and divide it by 0.5 to give us 12 times 1.5 to the n, and then minus 1 equals 79.125, right? Let's get rid of the divide both sides by 12 to get rid of that. So we have 79.125 divided by 12. We get some weird number here, 6.59375. All right, 6.59375 equals 1.5 to the n minus 1. Okay, so let's add 1 to both sides. 7.59375 equals 1.5 to the nth power. Now, whenever our variable is in the exponent, logarithms is usually the way we can go. You can also do this by graphing. You can plug in this on one equation and 1.5 to the n and see where they intersect. You can do that too. I just like doing logs. I find that it's faster. But you do what works for you. Log 7.59375 is going to equal log 1.5 to the n. Now this n can come out front, so it's n times log 1.5 log 7.59375. Divide both sides by log of 1.5. Right? And we get that n equals whatever log of that, this plus 1. So let's just do this plus 1. There's our 7.5935. And I'm going to do log of second answer. And then divide it by log of 1.5. And we get, magically, 5. Okay, sum of the first n terms of the sequence 79.125, find n. It's just, there's just 5 terms on that thing. Okay? All right. Last one to take a look at, 13. Consider the geometric sequence 160, 80, 40, 20. Find in decimal form the 8th term of the sequence. So we can tell that we're just multiplying. Officially, we want to multiply by 0.5 each time, right? Instead of saying divide by 2, but we could get there that way as well. So we're multiplying by 0.5 each time, and we're going to find the decimal form of the 8th term of the sequence. So, I mean, really, since there's so few to do, I think this qualifies under smarter, not harder. 1, 2, 3, 4. We want to do 5, 6, 7, 8. Okay, so 20 times 0.5 is 10. Half of 10 is 5. Half of 5 is 2.5. And then half of 2.5 is 1.25. There we go. Problem solved. Right? Don't even need our calculator for that one, do we? Okay. Second part, B, says find the sum of the first 8 terms of the sequence. So we can add that all up. I think our better bet is going to be to start using this because it's probably going to help us out later on anyway. So sum of the first 8 terms of the sequence is going to be the first term, 160, times our ratio, which is 0.5, to the n number of terms, 8. And then subtract 1 all over 0.5 minus 1, which leaves us with negative 0.5 in the denominator. So now we can just plug that into our calculator. And probably will help us for the next problem. Who knows? 160 times 0.5 to the 8th. And I got to get that back out of the power, and then minus 1, close our parentheses, equal negative 159, and then we're going to divide that by negative 0.5. 318.75. So 318.75 is the sum of the first 8 numbers, which are these here. Okay? Which kind of makes some sense because, look, you got the 0.25 and the 0.5, add those together, and look, there's your 0.75. Okay, last one. How many terms are required for the sum of the terms to exceed 319.9? So again, here's the good news. Look, we already came up with our sum formula. Now we're just use those same numbers there. Except for now we're going to put 319.9 equals 160. We now do not know how many terms there are, so we got to get rid of the 8. And we'd still do 0.5 to the n minus 1 all over 0.5 minus 1. So that's still negative 0.5 down here in the denominator. And if you take 160 divided by negative 0.5, that's basically, if you're dividing by half, that's doubling it. So that's 320, but it's negative 0.5 to the n minus 1, all equals 319.9. Add 320 to both, oh, excuse me, wrong. That is negative 320 times this, so we have to divide by negative 320. Which basically turns this into negative 1, doesn't it? Let's see what it actually gives us. So 319.9 divided by negative 320. Negative 0.9996875. Negative 0.999. 6875 equals 0.5 to the n minus 1. Oops. Add 1 to both sides. And we get, let's see, plus 1. It's going to give us something really close to 0, right? Ooh, not 8 plus 1. Where did that come from? Enter. Gives me that number back now. Oh, I'm struggling. Plus 1. There's our e to the negative 4, so that means move the decimal back 4 spots, so it's a bunch of zeros. Right? And then, let's see here. So we got, so really that e to the negative 4th, move the decimal 1, 2, 3, 4 spots, so it's 0.0003125 equals 0.5 to the n. Now we do logarithms. Log 0.0003125 equals log 0.5 to the n. N comes out front. And log 0.5 is log 0.0003125. And last step is divide both sides by log 0.5. Right? And so n will equal, so we're just going to take the log of that number there. It's already in there. So log second answer gives us negative 3.5. Divide that by log of 0.5, and that gives us 11.64 is n. So how many terms are required of the sum of the terms to exceed 319.9? So it'd have to be more than that. So we'd have to go up to n would have to equal 12 terms. Okay? Okay, that's all we have for the 5H assignment. If you have any further questions, please feel free to ask. Thanks.